In this video I'm going to show you how to make use of function number 3, and the purpose of that function in Modbus is to read a single holding register. So once you've written information into an EEPROM, you stored that setting. At some point you need to read that because maybe sometimes you want to change that, and this is the way how it can be done. Then again, I'm still making use of the same circuit diagram here. And of course I've got my master micro and I've got my slave 2 microcontroller here. So just like before, just like with the previous function, which was function number 6, first of all I need to write data into the holding register. So what I'm going to do in the master program is I'm definitely going to just see, yes, I'm definitely going to, first of all, like before, I've done this before, I've written into register number 401, I've written a value of hex 52, and in register number 403, that could be my water level water level, while this one could be my temperature, for instance, the setting. So yeah, I am going to also, like before, write AF0, which is 2800, and then what I'm going to do is I'm going to call this Modbus function number 3. You can see I'm going to do this before the while one loop, because it would be ridiculous to constantly read a single holding register. You would normally read the value and then do something about it, and that's it. So I'm just going to write the values like before, like in my previous video, on function number 6, and then I am going to basically just read one of them, which is the one sitting at 403. So I will write in there AF0 or 0AF0, which is 2800, and eventually I will need to see on my master that that is the real value that was stored in that specific address of 403. So again, this function I have written to give an argument, which is the slave address, and also then of course the holding register address. And as I've said before, the holding registers are basically sitting as from 401 upwards. It could also have been 4001 upwards, but we're just going to make use of the hundreds in this specific case. I deliberately didn't use the next one, 402. I just want to show you it can be anywhere where it was stored before. So if I go to this specific function here, you will see, where is it? Where's the function? Here it is. So there's my argument, which is just like before, the slave address, which is this one here. This is the address of the holding register, and again, just like before, I am subtracting 1 because we need to send a value if I want to read from whatever address. In this specific case, the address is 403, so address is actually going to change to 402. Function number 3, that's the one that will be sent, and of course if I do this, I will send the high address byte, and if I send this one, I will send the low address byte. And in this specific case, we are just going to do one register. I suppose it is possible to do more than one, but to read one at a specific moment is maybe the best thing that you can do. Okay, so this would be the function. The data would be sent, and it would tell the slave number 2 that it needs the information sitting in address 403. So if I go to my slave function we've seen before from the master micro, 6, as you can see here, 6 bytes will be sent, and it's function number 3. So on the slave, you will see when you get to the point as before, you will receive the data in this UART receive interrupt vector, and of course it will be slave number 2. So yes, this program here will be accessed, and of course as soon as all the data has been received, we are going to get to the point. This is function 4, 6. This is the one, yeah. Let me just switch that off. So 6 bytes were received, and it is definitely function number 3. Let me just remove this stuff also. Just build this thing. Just like before, I'm again collecting from element number 2 and 3 the input address, and I'm incrementing it by 1, and let's just remove this also, because that's not part of the program. Let's make it a little bit more streamlined. Okay, so this input address at this specific point will be at this stage it would actually be at 403. Yeah, that's the one, 403. So again, I've made use of a pointer. It's the same pointer as before, the holding register pointer, and I basically equated that to the address, and as you will see now, it's actually 403 minus 401, which is 2. In other words, it's the second element inside this holding reg, which will actually contain 403 address. And then just like before, I have, in this case now, I have only read the value, because previously it was already in function number 6 it was written into the EEPROM. Now I'm only reading it. So hold reg, it's an integer, and it will actually collect that specific value that you will find, which is at address 403. And of course it will then transmit back the slave address. It is function number 2, the byte count, which is 2, and this value that sits here. Now, like I've said before, just to come back to the master micro, we are basically going to focus on that one. I have written AF0 into address number 403, and yeah, that's what we are reading at this stage. So yes, you will find in here the upper byte will be actually A or 0A, and the lower byte will be what is that value now? F0, ne? Yeah, AF0. Good, and it will be transmitted. But what I've done in this program, I have just said, just to make sure what is happening, what is read from address 403. I'm saying let's just quickly display on port 3 the value of, and I should see 0A there, and then display this value, which is supposed to be F0, ne? Yeah, the lower part F0. So all of this will now be transmitted back to the master microcontroller as before, just like before. And in the master microcontroller, when you receive data, let me just go to this function. This is where we would be receiving the data, and when we get to the point where, which is F3, this is at F3 feedback received, the counter will be at 5, and also RX1, element 1 in RX array would be 03. So that is if function number 3 is giving a feedback. So what I'm doing here in this program, I'm just saying, for a short while, just display on port B the value 3, element 3 of this array, and then element 4, which is exactly the same. It should display 0AF0. That's what it should be displaying. And then right at the end, it must just display again on port B. So that part is the 0A, and that part is the F0, and it should be then displaying, well, 3 for function number 3. And then just clear the array as before. So that's basically a summary of how you would also make use of function number 3. So let's go back to this one. So we must just remember now, let me just stop here, that first of all the master, remember, let me just go back to the master program again. The first of all we would have written in there, just like before with the previous video that I've showed there, we will store in address 401 the value of 52, and then we will store the value of AF0, and if you can recall, I have also displayed that just to make sure that that is the value that was basically stored there. So then we would do this one, and then just go directly and just check what is happening in 403. So let's have a look at on the Proteus design how this will, what this will look like. So I'm gonna say what's gonna happen. I'll read what is actually happening on the outputs here, and let's see if that is actually conforming to what the program says it should be doing. So let me just stop, let me just start here. So the very first thing I will be seeing is there will be written 52, that hex 52, and it's going to be function 6. Then it will be F0, which is also function 6, as I've said there. So it's 52, which is function 6. There we can see it's function 6. Then it will be AF0, function 6. And then we will read from this one, and we will, if we read from this one, I should get back AF0, which is now function 3. And it should also, as I've shown you on the master program, also display on the port B of the master micro. So let's see what's happening. So on this side, you see 52, function 6, F0, function 6, it's written. Now we're reading F0, and it's transmitted to that side. F0, function 3. So this side was left with function 3 just displaying that it actually reacted on function number 3, and the same on this one. So you could see that I've written from this side into address 401 a value of hex 52. Then directly after that from the master I have written into this one a value of hex AF0 that was written into the positions, and then the master would request from this one, give the value from the slave, give the value of address 403. It actually collected the value. I just displayed it on the port that it is the correct value. It's then transmitting it back to the master, and the master is then displaying AF0 again on this one. And as I've said, I'm just stopping this by just showing it's function number 3, just to make sure that you know where you are. And this is actually the last of the videos that I'm going to make. I will at some point, I've given in class function number 2, I think it was, and 4 and so forth, and I'll make some videos on them also. But so today then we have covered, well, I've started off by making use of function number 15, just to again show you how we can write multiple coils. Then I have shown you function number 1, which is how to read coils. I have then shown you how to basically make use of function number 6 to write to a single register. And then I've also shown you now how to make use of function number 3 to read data. Sorry, to read data from a single holding register. And this basically, with these functions, we can cover everything that we need for our project, and basically for any project that makes use of Modbus function. So the functions I'm using here, function 1, function number 2, function 3, function 4, function 6, and function 15 is actually more than enough. We don't need more than that in order to make use of well, Modbus functions. That is it. We will have some discussions again in class, and I will give you I will basically tell you when you can ask me questions and have a discussion sessions, etc. Thank you.